solutions. They just want us to determine the solutions in one complete rotation, one full circle. So this is another function. That's why I wrote. So the sign exists. So there is something else about that. Okay, but this is not the issue. So all you have to remember, go back and look at the identities. So this is 2 sine x cosine x equals sine x. So this is the double angle identity. Now, the older versions of the book, they had in front cover, back cover, they had a lot of formulas, geometry, trig, etc., etc. I'm not sure if this one does. I have not looked. So once you start with this, from this point on, everything should be okay. Because you move sine, you factor out, and you're done. Do you want me to continue this, or is it clear? I mean, we did a problem like this in class, but if you need me to continue, I will.
No, we can take it offline if I need additional help.
So is that clear how we continue? So we will subtract sine and then factor out sine. So this is 2 cosine x minus 1 equals 0, and you have 2 options when sine x is 0 and then cosine x is 1/2.
Okay.
And then you have 0 in 2 situations, 0 and pi, and cosine 1/2, it has to be in the first and the fourth quadrants. So you get 2 solutions from here and 2 solutions from here in a full circle. Is that better?
Yeah, I mean, I need to brush up on these type of problems. So
this is, yes, it is very important because we're going to have trig situations the entire semester, yes.
Okay.
But is this okay, how to determine these solutions here in these 2?
Yeah, and if we went over it last class, I'll go back and I'll look at the lecture.
We reviewed the trig equation. I no longer have it, but I can bring it up online. I shredded, I mean, I recycled the papers.
Okay. Yeah, no, I think I'm okay. I don't want to take too much time away.
No, this is important because, you know, I'm sure others have the same question. This is very important. Anything else you would like to ask about any other problem? Anything else? Anyone else? Anyone? Everything else is okay? Christine, do you have anything else?
No, I mean, maybe like offline, can we look at my written homework together and we can go through it and you can tell me where my weaknesses are?
Sure.
Again, I don't know where my pitfalls are.
Okay. So do you have anything else for right now? No. Okay then. So I'm going to share my screen and go back to our text. Where are you guys? I switched and I can't see you anymore. Okay, I got it. Okay, so we looked at a few problems. I would like to identify something here. This is the problem that we just talked about at the end of last class, right? We reviewed it on paper. So as you see, in any situation in which the limit from one side, at least one limit, one from one side, it doesn't have to be on this side, but at least one. In this case, is both. They both sides, both left and right hand side limits go to infinity. This line is called, anyone remembers how is this line called?
That's a vertical asymptote.
Excellent. So in our case, so let me write it down for you here. This is problem 8 in 2.2. X equals -3 is a vertical asymptote. Okay. What about here? What can you say about x equals -1? Also a vertical asymptote. What will you say about x equals 2?
Another vertical asymptote.
Another vertical asymptote. So as long as at least one side goes to infinity, That is a vertical asymptote. Okay. I would like to look at this word problem. Real life situation, application if you want. A patient receives 150 milligrams injection of some medicine every 4 hours. The graph shows the amount f of t. So f of t is the amount of the medicine, the drug in the bloodstream after t hours. We're asked to find the limit as t approaches 12 from the left and as t approaches 12 from the right, and explain the significance of these one-sided limits. So here's 12. How much is the limit from the left?
From the left, that would be 150, correct?
Excellent. From the right?
300.
Excellent. From either side of 12?
That was, we said, cannot be computed, I think was the word.
The word, that's fine. The word is DNE. It does not exist. Excellent. So now it says explain the significance. So as you see what happens? He gets the medicine and then it dissipates in his bloodstream. It drops from 150 to whatever, probably 75 or 80 in 4 hours. Then he gets another medication, another shot. It drops down to a little bit higher this time in 4 hours. Then it gets another one right after 8 hours. And so on and so forth. So that's the explanation. Now, I would like us to choose a piecewise defined function because I would like to show another. And let me change my camera and go back for a second. So one comment I have in general, which I think I send you the comments in general, but I think no one showed the correct graph for the work for the piecewise defined function. So the steps have to be very clear. I know it looks very difficult. It's one of the easiest topics of this class. Trust me on that, please. I've been teaching this class for 20 some years. So if you follow me and if you watch the video again and if you do the work step by step, if you do it twice, then you will never forget the steps. And you're not going to show the work all over the place with all sorts of things or nothing. Okay? So let's do that. So I see something in the chat. Okay, no problem. Good. So I would like to share my screen again, and please choose a piecewise defined function and let's work on it. Either 11 or 12, and I think we have more somewhere or maybe not. After that, I would like to look at problems 15 through 18, and I'll let you choose whatever you want. So let's choose. Let's choose 11 only because I like to review the exponential and the natural log. Is that okay? Okay then. So let's start with 11. Let me copy it and then I'll stop sharing. So this is 11 in section 2.2, and we have f of x equals e to the x for x less than or equal to 0, x minus 1 for 0 less than x less than 1, and then natural log x for x greater than or equal to 1. Okay, I'm going to stop sharing now. Where are you guys? Okay. Now, what we reviewed so far, let me just refresh your memory. So number one, we looked at linear, right? I don't want to talk about linear again unless we have to, of course. Number two, quadratic. Anyone has any difficulties with any of this, speak up. There is no, problem. I can go back to any of that. The other function that we looked at and we graphed was f of x equals arc tangent x. So moving forward, these should be carved in stone. Also, what else should be carved in stone is square root, absolute value, cube root. So these should be carved in stone at least, you know, anyway, if you have any questions, I can show any example. So now I'm going to add number 7 and number 8. And this is number 7, e to the x. And this is number 8, which is natural log x. So moving forward, when we talk about these, you should have the graph in front of you, in your memory somewhere, so we don't have to explain this again. There is no problem.
Excuse me?
Yes?
We can't see the paper.
I'm sorry. I'm sorry. I'm sorry. I forgot to switch. Sorry about that. Okay, so it was problem 11. I have to start from scratch now. Problem 11 on 2.2, so I copied the problem. So here on the side, I was listing functions that we should not have difficulties with moving forward, right? Linear, quadratic, arctangent is the one that we graphed at the end of the first class last week. The square root, if you have any questions about that, I will show an example. Absolute value, I will show an example. The cube root, I will show an example if you need to. And now this is the function that I'm talking about, the natural exponential function and the natural log. So once we think of these, we should just see them with the mind's eyes. Okay? So before I even address this, I like to start with e to the x. So the exponential function has different possibilities. It has a base, which is, so the function looks like this, base raised to x. And there are two possibilities, for the base to be greater than 1 or for the base to be between 0 and 1. The shapes are different, if you remember. This one will always be increasing on all its domain, and this one will always be decreasing on all its domain. E to the x fits this category, meaning this. Please, when you graph anything, here I'm not graphing a function, I'm just showing the shape. Remember the 4 steps: domain, table of ordered pairs, graph, and range. If I don't see those 4 steps, I can't give any credit, so sorry. Please label the coordinates. The origin, x is the x-axis and y is the y-axis. Again, I'm only graphing e to the x, which looks like this. And it must cross at 0, 1. Why? Because when x is 0, e to 0 is 1. So this is the graph of e to the x. You always have to label all these. I didn't think I had to say that because that's what I showed, but apparently I have to. The x-axis, the y-axis, the origin, the graph, the intercepts, and what is the graph all about. So you don't make me guess. I don't make you guess. Okay, I'm just going to graph with a different color, the base less than 1. Notice that the base cannot be 0, cannot be 1, and it cannot be negative. So this is something that looks like this. So this is a to the x for a between 0 and 1. Unfortunately, the pandemic is this function. 10 people get sick today, 500 tomorrow, 10,000 the next day. It's a hellish graph, hellish trend. I never thought I would say that to my students. Okay, that's what we are facing. And when we say we flatten the curve, we really want this. We want this, right? But at least not this, at least this. We can live with that, maybe. Okay, so this is the exponential function. Now the log function is the inverse of this one. They are inverses of each other. So here is natural log. So if this is e to the x, I'm going to graph it here. The origin x, y, here is the graph. I don't want it solid because this graph will represent more natural log. You draw y equals x, which bisects the first and the third quadrants. And exactly symmetric on the other side, we have If this is 0, 1, this must be 1, 0. Exactly opposite is this graph of its inverse function, natural log x. If I want to fold the graph on y equals x, these two should completely overlap each other. This is always the case with two functions that are inverses of each other. Always. What about this one? Of course, this one has, maybe I shouldn't put it here, the decreasing function. I don't want to put too much on that. Okay, so let me also graph the other one. So if this is the inverse function, which is which is the exponential function with a big tiny positive x 0 y. This is the function. I cannot graph before I draw y equals x. First, I have to draw y equals x. And now I can draw the inverse function carefully, showing that this point does not move anywhere. This point is 0, 1, therefore this one must be 1, 0. And this, because it doesn't move anywhere, it has to be part of both graphs. And this is log base a of x when a is a tiny positive number. Again, if you fold the graph, these two should overlap. This piece should overlap this, identical. This piece should overlap this, identical. My graph is not perfect, but just remember when you graph the inverse functions on the same coordinate system, you have to graph y equals x first so you can get the point. In this particular case, this function did not touch y equals x, so this one can't, right? But if one function crosses y equals x at the same very point, the inverse function will have to cross. Any questions so far?